There we go.
Okay, cool.
Hey, Kevin. How's it going?
Fine. Thanks for having me, guys.
Good morning.
Yeah.
The hotel comfortable?
Everything's good.
Everything's
it's all good.
Cool. Well,
Well, thanks for your time this morning. I'm kind of just like to jump right into it, so I'm going to put you on the spot.
Okay, sure.
I'm going to ask 2 questions,
Sure.
and you can answer them together or separately. But tell me what you understand about this position, and then tell me why you're the perfect fit for it. And in there, please tell me, so it's kind of 3 questions, why you're not. What are your weaknesses? What are you going to have to pick up before you are effective at this position?
Okay. First off, it's a position of significant responsibility, being the chief engineer at the battleground plant. Safety is paramount. It's really not a priority. It's nothing ever to be prioritized. It's pretty much automatic with all my activities that I'm involved with at the battleground plant. So after safety, there is all of the technical responsibilities associated with the process for all the products being manufactured at the plant. PIDs, PFDs, everything that's illustrated there in the job description, interfacing with contractors, maintenance, operators at the plant, outside engineering consultants, and other junior engineers that are involved in the day-to-day activities, all in the efforts to support safe and reliable operation and production at the battleground plant. Additionally, the other projects that were alluded to in the job description that talk about capital development expansions at the chemicals plant, defects that are currently in need of addressing to improve the process of any and all of the product lines at the plant, and then becoming a technical steward for the technology, really. And I actually pride myself in becoming a technical steward for the technology. So that's the job description. I think that I believe that I'm the perfect fit for the job because of my 16 plus years of skills, knowledges, abilities across multiple industries and disciplines, my contributions and accomplishments in those areas, specifically in oil and gas and mainstream process engineering, everything ranging from ethanol to refining to gas processing. And I think the transition over to this technology and chemicals will be rather easy, because there's going to be a learning curve, which this is a segue into the second part of the question, that I think it's going to be a lot easier for me versus other engineers because of my extensive technical background to pick up on the technology very quickly and be able to move the projects forward, driving towards the goals that are needed for the business unit and the plant. So my effectiveness in working with maintenance, operators, everything from IT to contractors will lend itself to be very useful in making these things, these goals become a reality. So having said that, I think that really makes me more than a perfect fit, an ideal fit for the position and the business unit.
thank you. What's the largest team of people that you've worked with, that you've managed up until this point?
I've never been a direct supervisor, engineering supervisor before, so I never had really direct reports. I've managed projects that had team members in the project that there was some supervision involved, being a project manager, and that team range, team size ranged from anywhere from 6 to 22, about, depending on the duration. I shouldn't say the duration. Where we were in the project early on, it started off as half a dozen people, and then as a project went to the execution phase, there were contractors involved and other discipline engineers involved. Team size went up respectively at different stages and milestones within the project, and then of course ramped down towards closeout. So anywhere between 6 and 22, I would say.
How long do those projects last?
The longest one was 16 months. Another one that had to do with the chilled water plant. Well, the one that was 16 months was at a refinery, the Citgo refinery in Lamont. The one that was more towards, I think, a little more than a year was Alcatel-Lucent. That was a chilled water plant at the old Bell Labs, 2 chilled water plants. And I was the project manager for that project as well.
Okay. And are those other engineers as well?
Engineers, contractors, maintenance, those 3 on the Alcatel-Lucent.
Okay.
So back on the technical aspects that you're going to have to pick up, I like the fact that you're confident that you can pick that up quickly. What makes you confident? What would be your first order of business to start that process?
Study up. I'm a good student. I'm a great student. I'm an outstanding student. And when I started at ConocoPhillips, I had never worked at a gas plant before. And I went in there as a senior process engineer, and within 5 hitches, I had the entire process down, including utilities and the glycol dehydration unit. So a hitch being 14 days. I worked a 14-day hitch and 14 days off. And so after 5 hitches, complete process down. So I think the gas processing process, from what I understand at this point, is probably more complex, being the fact that I could come from a sour gas plant in Wyoming. I think would be a very short time period, maybe 90 days for me to get all the processes down, working a 5-day work week. So I think the safety requirements are going to be very similar, having come from a very sour gas facility at ConocoPhillips where it's highly poisonous. You have to carry a 5-minute gas bottle into the plant at all times, in addition to all the PPE gas running. I'm assuming this is probably going to be the same safety requirements because we're dealing with chlorine gas, hydrogen gas, and so I'm guessing it's going to be on the same order of importance and danger that what it is I saw at Lost Cabin.
How do you handle anticipating problems before they become emergencies? Especially with something you're unfamiliar with.
I guess be in constant daily communication with operations and maintenance on my daily tasks, so that as I'm learning and as I'm absorbing, as I'm moving things forward, there's another set of eyes and ears that are fully aware of my activities on a daily basis, so that something doesn't get overlooked, nobody gets hurt. Things are done reliably, safely, and correctly, and excessive monies aren't spent, people's times aren't wasted, and these are the kind of things I did at Lost Cabin when I first started. I was working very closely with operations on a daily basis because I needed their help. I was new to the gas plant, and I really needed their help, and they helped me out. They would stop whatever it is they're doing. If I asked a question, I said, "This is valve. What it is it's going to do?" They would stop and tell you what it would do. Very helpful, and it was very important for me to establish that strong working relationship right out of the gate, which would really help me out with the position and the growth in the position when it first started.
What if they don't tell you?
I think most people will if you need their help and you genuinely go and ask them, hey, I'm trying to get this done, I need your help. They're going to help you out, unless they don't like you. So my experiences on that front have been actually very positive.
So share some specific examples of where you had the project and it was going along and you actually saw something ahead of time, and how did you approach that, and what was the possible outcome versus the actual outcome, because you actually hit it on.
I was working on the acid delivery system out at Lost Cabin, and they were injecting sulfuric acid. We were injecting sulfuric acid into the produced water stripper to manage the pH in the vessel so the separation could take place. That was the situation. So the acid would be delivered to the plant on a intermittent basis based on consumption and the need. So a truck would arrive at the plant, and they would pump it into a large 5,000 plus gallon, 5,250 gallon tank. And so a lot of work was being done on the acid delivery system, everything from the tank, the pump box, all of the plumbing, all the way up to the quill and the injection point. There were a lot of leaks, and so safety was a huge, mega concern, to be honest about it, a real large, very important concern, paramount concern. So inside the containment pit, we had so many leaks that I was working on because we had to eventually end up changing over materials, plumbing materials, pump materials, everything. I suggested, in conjunction with the HSC department, splash guards. Splash guards being, it's a shield that you put over your construction helmet. And I mean, you usually have your safety glasses on in the plant, that's mandatory anyways, but a splash guard.
Right,
Because
protect your skin.
Right, and the truck drivers, the delivery truck drivers, they have splash guards, and I was talking to them about it, and that's where I got the idea. And I went to HSC. I said, maybe we should do that same thing. I said, yeah, we don't want to get sprayed. We don't want to look like Frankenstein. I understand that. So I went to the HSC department and suggested this as an idea, and it got kicked off pretty much right away. And I don't want to say it was all my idea. It was discussed with the operators when we were out there during the loading procedure. We were talking to the driver, myself, and another operator. Like, we need to do something. This could be done better, because somebody could open up the pump box and then there's another leak, and no one wants to get sprayed with sulfuric acid, obviously. So that's one. What ended up happening was HSC spearheaded putting a box in next to the acid pit with splash guards. So it became a protocol, a safety protocol. If you're going to go enter the acid pit, go down the stairway into the pit, put on a safety splash guard. And there's a box of them right outside the acid pit. You just go and put it over your helmet. And that was very helpful. I think that avoided someone getting very seriously injured. So that's an example of one of the things I was involved with.
How about a different kind of an example where something might have been going on, and you had to take a stand, basically, an unpopular issue for the project, where you had to, bring it up and then work through some trials and tribulations that weren't so popular with the team, with the management, or both ways, but you felt strongly enough and you stood your ground, and you had to make sure it happened properly, or make sure something,
Right, sure. One of the things we had to do, because of all these leaks in the acid area, I guess we could stay on that same topic since there's already a background. We had all these leaks, everything from the tank, the pump box, plumbing, all the way up to the injection point where the quill's at. So my boss came in and said, Kevin, we need a solution. We need a solution. You need to get on this right away. I don't need to see your computations or your sketches, whatever you need to do. Just come to me with a solution. I don't have time to work on it, but we really need something, because it's just one leak right after another, and it's dangerous. So I went and I discovered we could use CPVC, chlorinated polyvinyl chloride. And I went to the Cole Palmer website. Cole Palmer has a built-in menu where there's three parameters. There's a material selection, fluids to be handled, and then a rating. Excellent, good, poor, fair. And then, you select your fluid, and either from nitric acid, hydrochloric acid, sulfuric acid, CO2, whatever the gases, and then your material. You use Hastelloy, Inconel, stainless, PVC, CPVC, whatever, and exotic metals. And so I went to my boss and said, look, we should use CPVC, and this is why. And I showed him the documentation and where it was used before, successfully. Great idea, Kevin. Let's go forward. And by the way, let's use Schedule 80. I know you have Schedule 40 listed here. Let's use Schedule 80, which is a heavier gauge pipe.
It's not twice.
It's like twice. It's close to twice. Yeah. So I said, great idea, Mike. And so went in, got a vendor quote. We went, loaded everything in SAP to get a purchase order, all of that kind of things. And at the same time, I went to maintenance. The superintendent said, this is what we want to do. This is what we would like to do. This is what we want to, we want to get you guys on board with this. And they weren't on board at all. They didn't like the use of plastic. The fitting's got to be glued. It wasn't real stiff. It might crack because of the temperatures. It gets cold in Wyoming.
Or vibration, or flux.
Exactly. And they thought it was going to be another disaster. And I showed them all my stuff, and they're like, yeah, I know you're showing me these things. I don't feel comfortable. And the guys don't feel comfortable. I said, oh, I know how the guys feel. I talked to them first before I came to your office. They already know what I'm trying to do. And they're not upset with me, but they're concerned that it's not going to work. It's not going to pan out. And I said, we got to make a change. We can't stay with the Inconel and Hastelloy as it is right now. Well, you understand we got to make changes. But we have a lot of reservations. So what ended up happening is they were like, okay, we're gonna trust you on this. But if things don't pan out, I'm gonna be in your office and we are gonna drop the hammer on you, Saka. They said it just like that. I said, no, that's fine. I mean, something has to be done. If it doesn't work out, you can come and I'll take the responsibility for it. It's my. So after 2 months, everything worked fine. The leaks were fixed. We had heat traced and insulated. Everything worked out great. And so I think it gained a certain set of confidence with the maintenance operations. My boss is on board right out of the gate anyways. So there was really no convincing the engineering supervisor. But the maintenance mechanics, there was some intellectual resistance. And I didn't want to see anybody get hurt. We knew we had to make a change over something. So it got a good rating, and in the end it worked out. But there was some unsmooth territory to navigate.
Okay. Excuse me.
So has your team taken care of documentation, or have you been directly responsible for preparation of the PFDs or PIDs or whatever? Are you the author?
Both. I've been involved in both. I've also been involved in estimating the time and hours required to develop a PFD, a PNID, and data sheets of various different types of equipment and other stuffs. So typically, the person that checks, we could use a data sheet, for example. It's an 8.5 by 11. I'm sure you know what those are. They fill out specifications for a pump, or maybe a heat exchanger, materials of construction, pump curves, all of those things that would go into a pump data sheet or a heat exchanger. So typically an engineer would work on a data sheet, and then a different engineer would check the data sheet, and there's hours associated with depending on the complexity of the equipment, how many hours are going to be to develop the sheet, do the calculations, how many hours to check the sheet before it's ready to go out the door to the client. So I've been intimately involved with all aspects of the data sheets, also the PNIDs and PFDs, same thing. It's usually checked by another set of eyes than the author of the document. Same thing with the calculations. And then to expound on that, the engineering specifications as well. Follow this kind of the similar protocol. So when a consultant would come to the chemicals plant with their data sheets, that's very familiar ground for me. The PFDs, the PNIDs, all that kind of documentation stuff we're going to bring. Data sheets, specifications, even their handmade, homemade calculations. I'm good at checking that kind of stuff too. So that's very familiar territory for me.
How are you going to handle troubleshooting something you're unfamiliar with?
Operations. Operations is number one. When I was out at Lost Cabin, that's exactly what I did. When I was new to the plant and I was working on a problem pretty much right away, I had to get them involved because there's stuff I need to be debriefed on, and my studies and solution planning needs to be very directed constructively pretty much right away. And it's a team effort, but me trying to just look at a vessel and just come up with a solution right away, not exactly going to happen. I'm going to have to work with others. So when I did that out at Lost Cabin, it proved to be very successful. And even if I'm very familiar, still I talk to operations, because still I might overlook something, and it's in their area where they're working, so they should know anyways.
Okay, since you're talking about working with operations, delve a little bit deeper into that. You said you haven't been a people manager as in the HR aspects of managing people, but you've been a project manager, obviously, so you're managing people.
Right, sure.
What's your management style? How do you prefer to interact with people, and how do you keep track of all the things that a project manager has to keep track of?
Okay. Can I answer that in a two-part answer?
Absolutely.
Okay, so the first part,
We've got 5 minutes of space left on your
okay, that's fine.
recording.
Sure. So the way I interact with, let's just say, out at Lost Cabin, I was a senior process engineer, which is not a supervisor, but there was a large group of engineers. Too many engineers. That's why we got laid off. But too many engineers in the group. So the supervisor didn't really have a chance or an opportunity to interact with all of the engineers on their daily tasks and all the projects they got, capital development, things around going on in each and any of the trains, the gas plants. So kind of deferred to me and kept work with these younger engineers. They're going to get stuck. They're going to need some help. And I'm going to trust that you could work with them so they could get unstuck, because I don't have the time to get all involved in the nitty-gritties, pump sizing, whatever. Sure, not a problem, Mike. So then what they would do is they'd come to my office and I would look at something, and one of them was an acid injection skid that I suggested. He wanted to come and make another tank, install another acid tank, and I was like, well, why don't we get an acid injection skid and do our own mix, and that will save a lot of space rather than have to double the pit size and tear up some plumbing. We could get an acid injection skid and mix utility water. It's going to save a. I said, but run it by the supervisor, see what he says. Talk to Mike about it. He's the boss. So he comes back and says, oh, Mike likes that. He says he wants me to help, to get more input on what I should do. I said, okay, I'll tell you what, we'll find some vendors. And then in a day or two, come back, let me know what you found out. So then he'd come back and I'd say, okay, these people are in the UK, let's forget about them. These people here are local in Utah. Let's see what they have. Get on their site. Okay, let's get some cut sheets together. You can make some measurements out in the pit, acid pit, and see what's going to fit, how much room we have. Let me know if you need to go out and plant. So it was interactive. They would go and do something, and come back, and we'd have a little mini review, and then he'd go. And that's the way it was with like 4 of the different engineers in the group. And so I'm not really micromanaging their work. I don't have time to get into all the details. I kind of give them a little bit of direction. They go and do some stuffs, and they come back, and it's interactive. So that, I think, paints a picture of what I'm like, potentially like as a supervisor. I'm not going to get involved in the nitty-gritties. As far as tracking the projects and where things are, I have a worksheet, an Excel file called a DTSR. That stands for Design Task Status Report. And it's a pretty massive Excel file with different worksheets, tabs across the bottom, broken down by discipline, everything from mechanical, electrical, plumbing, piping, welding, everything. So it's broken down by trades, design time, construction time, problems, variances, all those things are in that spreadsheet. So that's what I use to track, and I use it as a tool for reporting services, although I don't get management bogged down with that massive file. I'm not going to send that to management. I have another file that I could dump to a two-page summary. It's a graphical depiction of the milestones, the budget, the schedule. It's got a little paragraph for notes, and it's got a little paragraph for potential obstacles and challenges that are coming down that need to be addressed. I got it down to 2 pages, so it's a data dump from the DTSR to another reporting services worksheet that's turned out to be very handy.
Okay. What in your experience you think is the least likely to look like it has application to your job that does?
Probably the automotive.
How so?
The automotive industry is completely different than oil and gas and petrochemicals. The oil and gas and process engineering experience I have, it will lend itself very handily to this position and to the organization. I think automotive is, there's manufacturing involved. I think there was heat exchangers. I was in HVAC and climate control, so I know about HVAC in automobiles and in buildings. So I guess there's a little bit of crossover from automotive, but not a lot.
Okay. Thank you.
Sure.
One last question. You semi-answered it, but be specific on another project or when you came on to a new project. How do you establish trust and respect?
Okay. I think when I first come on the project, I really don't say much. I just kind of just sit and observe and absorb as much as I can and just try to come up to speed. So initially, I'm not going to really say a whole lot. To establish trust, I guess conveying any challenges or weaknesses I may have that might present a risk to the project, so that everyone